The universe is the oldest crime scene in existence, and we are standing inside it.
Every atom in you is evidence. Every photon is a witness. The question is, what happened first?
We call it the Big Bang. But that name hides a deeper mystery. What does beginning even mean?
Because time might not be a background. Time might be the thing the universe is made of. So tonight, we'll open the open.
We'll follow the evidence, then meet the puzzles and the hypotheses that live in the dark.
First clue, the universe is expanding. On average, distant galaxies are rushing away from each other.
Run expansion backward and everything gets denser, hotter, and closer, like rewinding a film of space.
Second clue, the cosmic microwave background, a faint afterglow from when the universe became transparent. It's almost perfectly uniform, with tiny ripples, the baby fingerprints of structure.
Third clue, the light elements. In the first minutes, the cosmos forged hydrogen, helium, and traces of others.
Those abundances match the hot Big Bang's predictions surprisingly well across the observable universe. Expansion, afterglow, light elements. Together they tell the same story. It used to be hotter and denser. But they don't tell us what started it. They only tell us what the universe looked like very early. And there is a limit. Beyond a certain moment, our equations become a warning sign.
Still, we can push closer, not by looking for light, but by reading consequences.
Because the earlier you go, the simpler the ingredients become. Atoms, then nuclei, then particles.
At the deepest level, nature looks less like objects and more like fields, fluctuating everywhere.
So the origin question becomes two questions. What shaped the early universe? And why is there something at all?
We'll take the physics door first. Then we'll come back for the second.
In the first fraction of a second, the universe may have expanded insanely fast, a phase called inflation.
Inflation helps explain why the cosmos looks so flat and uniform, yet still contains tiny ripples.
Those ripples later became galaxies. In a sense, everything you see began as a whisper in a field. But inflation is still on trial. We look for its fingerprints in the polarization of the cosmic afterglow. So far, experiments set stronger limits, narrowing which inflation stories can survive. And precision maps of the afterglow constrain the early universe tightly, leaving little room for exotic beginnings. Before atoms, the universe was a plasma, so hot that matter couldn't hold together in familiar forms.
Cooling changed the rules. Quarks bound into protons and neutrons. The raw material of chemistry appeared.
In the first 3 minutes, nucleosynthesis built helium and deuterium, the universe's earliest chemistry.
For hundreds of thousands of years, light couldn't travel freely. Photons kept colliding with charged particles.
Then electrons joined nuclei. Atoms formed. The universe became transparent, and the afterglow was released.
We still see that light today. It surrounds us. A snapshot of the universe as a newborn.
After that came darkness. No stars yet, only cooling gas and gravity quietly writing the next chapter.
Gravity amplified tiny differences. Denser regions pulled in more gas, becoming cosmic seeds.
Eventually, the first stars turned on, and the universe learned how to make light again.
Stars gathered into galaxies, galaxies into clusters, a cosmic web stretching across billions of light years. On the largest scales, the universe looks like a neural network. Filaments, nodes, and vast voids.
And somewhere on a small planet, consciousness appeared, the universe making a map of itself.
But there's a problem. The web is too sturdy to be built by normal matter alone.
Something unseen, dark matter, adds gravity without light, shaping structure like invisible scaffolding.
We infer it from how galaxies rotate, how clusters bend light, and how the early universe evolved.
Different clues point to the same conclusion. Most matter is invisible to our eyes. And yet we still don't know what dark matter is.
Another problem appears late in time. The expansion of the universe is speeding up.
We call the cause dark energy, a name that explains nothing and quietly admits ignorance.
It might be a constant energy of space, or something that changes over time. The data is still arguing.
So our origin story has supporting actors we can't see, dark matter and dark energy, steering the plot.
Now comes the most unsettling part. Even with all this, the numbers don't fully agree.
When we measure today's expansion rate in different ways, we get different answers. This is the Hubble tension.
New measurements with modern telescopes have checked key systematics, and the tension refuses to vanish.
If the mismatch is real, something in our standard picture might be incomplete.
One possibility, early universe physics was slightly different. Perhaps a short-lived ingredient that changed expansion. Models like early dark energy explode that idea, but they must satisfy a ruthless set of constraints.
Then came James Webb. It showed galaxies appearing shockingly early, bright and massive in the cosmic dawn.
Some tensions softened with better data and modeling, but Webb still expanded the list of questions.
One mystery, the little red dots, compact red objects that may be young black holes hidden in gas cocoons.
If so, they could explain how supermassive black holes grew so fast, so early, without breaking every rule at once.
Webb also found clues that some early galaxies aged fast, quenched by black holes, a slow death by 1,000 cuts.
So the origin story is not settled. It is alive, a living argument written in data.
And our biggest mysteries cluster into three groups: what began expansion, what the universe is made of, and what laws decide. Now we approach the forbidden question. Is there a meaningful before the Big Bang?
Science can't currently see behind that curtain, but it can propose ways the curtain might exist. So here are the leading families of hypotheses, not as answers, but as maps.
Hypothesis 1. Inflation was driven by a field. A tiny patch of space inflated, then decayed into hot matter and light. In this view, the Big Bang is not the start of everything. It is the end of inflation, when reheating filled space. Some versions suggest many bubbles form, a multiverse of regions with different conditions. We only see ours.
This is speculative. It may be real. Or it may be a beautiful story our math can tell, but nature never uses.
Hypothesis 2. A bounce. Instead of a beginning, there was a previous universe that contracted and rebounded.
A bounce could avoid an initial singularity, but it must explain why the universe looks so uniform and flat today.
Hypothesis 3. A cyclic cosmos. Expansion and renewal repeating in vast epochs, like cosmic breathing. Some ideas imagine the far future becomes mathematically similar to a new beginning, linking eras without a hard start.
Another family. Holographic ideas. Perhaps the universe's information.
If space can emerge, time might emerge too. Not fundamental, but a consequence of deeper relationships.
That would change the question from what happened before time to how does time come into existence at all?
And at the smallest scales, quantum mechanics complicates everything. Observation, probability,
and what happens means.
Some proposals begin with quantum fluctuations of fields, not nothing, but the most minimal something our theories allow. But to be confident, we need a theory of quantum gravity, a framework that unites space-time with quantum rules. Candidates exist, but none is confirmed. Right now, the origin remains a frontier, not a finished chapter.
So what do we do with an origin we can't fully see? We do what science always does. We build better questions.
Cosmology advances when the very large and the very small meet, in background light, in particles, in precision. New surveys keep arriving. Some even hint dark energy might change over time, and that would reshape our future. Depending on what dark energy is, the universe could drift into cold quiet, or surprise us with a new phase. But notice something. The unknown is not a wall. It is a horizon. It moves when you walk toward it.
We used to not know what galaxies were, or what atoms were. Mystery is simply ignorance waiting to be shaped.
And while the universe may be indifferent, your life is not. Meaning is something minds create against entropy.
If time began with a whisper, then every conscious moment is the universe learning to listen to itself. So the origin story ends the same way it begins, not with certainty, but with wonder, disciplined by evidence. And that combination, wonder and evidence, is how we keep the universe honest without losing the mystery. We don't yet know what lit the first spark, but we know the shape of the questions it left behind. And every new measurement is a small act of time travel, a way to read the universe's earliest memory. If you felt that choir thrill of not knowing, you're already part of the story. On Arcane Knowledge, we explore science at the edge of mystery, in calm terms. If you want the next chapter, tap like and subscribe.
And place one small memory pin with us before the universe turns the page again.